Welcome to Mars Saga, your gateway to the Red Planet. Subscribe now and join the journey.
Hey explorers, welcome back to Mars Saga, the place where every grain of Martian dust hides a forgotten chapter of the universe. Today's episode takes us into one of the most mysterious regions on the Red Planet, an area scientists once ignored, but which now appears to hold clues to a lost Martian past. So buckle in, stay curious, and let's dive into another journey across the silent world of Mars. For years, the region known as Elysium Planitia was considered nothing more than a flat plain of hardened lava, a smooth wasteland, a boring spot on an exciting planet. But then, as often happens in science, everything changed when fresh data arrived. NASA's InSight lander detected unusual vibrations here, and orbiters saw patterns on the ground that didn't match volcanic plains. Something else was happening under this flat land. Then came the images, strange ripple-like lines spreading across the surface. At first, researchers thought they were dunes shaped by wind, but after careful analysis, they realized the lines were too smooth, too curved, and too connected. These weren't dunes. They were collapse tracks. Collapse tracks form when something hollow below the surface slowly sinks. On Earth, this happens above caves, underground rivers, or ice pockets. But on Mars, no one expected this. For collapse tracks to form, something beneath the ground had to melt, shift, or drain. And since Mars has no liquid water on the surface, scientists wondered if melted ice might be moving deep below the crust. Around the same time, new radar scans revealed faint reflections under Elysium Planitia, signals bouncing off something smooth, not rock, not dust, something more reflective, something that behaved like ice. This discovery triggered a new theory. What if Mars still has underground glaciers? These glaciers wouldn't look like Earth's glaciers, no towering white cliffs or frozen oceans. Instead, they would be buried under meters of dust and volcanic rock, protected from sunlight from millions of years. Over time, pressure could reshape them, causing slow internal flows. These movements might be exactly what created the collapse track seen from orbit. If Mars does have these hidden glaciers, it would mean the planet's climate was far more dynamic than expected. It would also mean future astronauts might have access to huge water supplies just below the surface. But the mystery deepened even further. As models of the underground layers improved, scientists found something unusual: heat signatures right beneath the glacier-like structures. They weren't strong enough to indicate active magma, but they also weren't typical of cold Martian plains. Something was warming those underground zones. Some experts suggested geothermal pockets, warm rocks left over from ancient volcanic activity. Others wondered whether those zones might have once hosted hot springs. Hot springs on Earth often host thriving microbial ecosystems. If Mars had them long ago, they might have supported life too. Meanwhile, the story took another twist when older mission photos were re-examined. In images from the Viking landers in the 1970s, researchers noticed strange bumps, small dome-like structures poking out of the ground. They were dismissed decades ago as erosion features, but now with everything we know, some of these bumps look suspiciously like pressure mounds, created when ice expands and pushes rock upward. In other words, these domes may be ancient frozen bubbles, proof that water once tried to rise to the surface. Connecting all these clues together, collapse tracks, radar reflections, heat pockets, pressure mounds, scientists now believe Elysium Planitia may be sitting above one of the largest buried ice systems on Mars, a frozen world under a dead world. And if this ice ever melted in the past, it could have carved underground channels that acted like rivers of cold liquid water. These hidden rivers might have existed long after Mars lost its thick atmosphere. Some experts believe that deep beneath Elysium, tiny pockets of brine water could still exist today, protected from evaporation by thick layers of rock and dust. This idea is thrilling because briny water can remain liquid even in extreme cold. And where liquid water persists, even in small amounts, the possibility of ancient microbial life becomes stronger than ever before. Future missions are already being designed to explore this region in new ways. One